Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Proclivity by Nicholas Duhale, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. The sum of the digits along an arrow is equal to the digit in the connected circle. So, for example, if this were, say, 3 and 3, this would have to be 6, because the digits along the arrow must add up to the digit that's in the connected circle. And that's an example of how arrows work. We also have digits along the indicated diagonal must sum to the given total, and digits may repeat if allowed by other rules. So, for example, say we had an 8, a 6, and a 2 here. Then this would have to be a 2, because this diagonal must add up to 18, and we have 8, 6, and 2 here. That adds up to 16. 16 plus 2 then adds up to 18. So that's an example, and these are known as little killers. So that's an example of how little killers work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. All of these sums are even sums. Anytime you have an arrow along the diagonal, the digits on the arrow sum to the same sum as the digit in the circle. So because of that, these are essentially equal to 2 times the digit in the circle, which is an even sum. So along the diagonal here, since this is an even sum and this is an even sum, this must be an even digit to add up with the even sum here to add up to an even sum along the diagonal. Same with this. This is an even sum here. This is an even sum here. That's an even sum here, so this must be even along this diagonal. Same along this diagonal. Even sum, even sum. This must be even. Now, to add up to an even sum here, this must be even. So we have 4 evens in row 4, which means the rest of the digits are odd. Let's go along this. This is even sum here, so this must be even here. Think we have the similar situation here. This is even here, so to make that, this is an even sum here, even sum. Even adds up to an even sum. Same with this. Even here, the remaining digit must be even. And to add up to an even sum here, these must be even. We have 4 even sums in column 4 and box 5, so the rest are all odd. The sum of 2 digits in the same row, if they're both even, can only be 6 or 8. Because you can't have 2 even digits adding up to less than 6, right? Unless you have a 0, but that's not allowed, obviously, in normal Sudoku. So minimum's 2 and 4 adding up to 6 or 8. So this has to be a 2-4 pair here. What else do we have? So this digit cannot be, it can be 2, 4, or 6 because it's less than that digit there. This adds up to 38 here, and 4 is the largest digit here. What happens if we have 2 here? That would be 36. So this is 2 times this digit and 2 times that digit. So 2 would require them both to be 9? Yeah, 9 times 2 times, and then 9 times 2 plus 9 times 2 is 36. 36 plus 2 would be 38. So these could be 9. Or can this be 4? If this is 4, that means they add up to 34, which is 17, which would be 8 and 9. So at least one of these is a 9. And it could be 8 or 9. Okay. Same with 6 and 8 here, I think, right? 42 minus 8 is 34. Can you have 2 digits here, which add up to 34, without a 9? Can you actually have this be 7 is kind of the question, right? And I think the answer is no. If you have 8 here, 42 minus 8 is 34. And this would be 7. 7 times 2 is 14. So 34 minus 14 would be 20, which divided by 2 would be 10 as a digit, which is not possible. So this has to be 9. And since this is 9, this can't be 9. That's 8, which means this can't be 8. That's 6, which makes that an 8. 6, this is 8 again, and this is at most 8 and 9, which is then 17 times 2, which is 34, which forces this to be a 4, which makes this 4 and 2. This can't be 4 and 4 anyway, so this is 2 and 6, adding up to 8. We have 8 here. This is 4. This is an even digit, and this must be odd because it must be 9. To get an even sum from an odd digit, it must add up with another odd digit, so that's odd. This is 9. 34 minus 6 is 28. This is at most a 7. But we could have 7 and... So 28 divided by 2 is 14. So this could be 7 and 7, or it could be 5 and 9. Either way, this is guaranteed to be odd. To sum up to an odd sum, we need, with 2 digits, it must be 1 odd and 1 even, so therefore this is even. This is 2. That means the sum on this diagonal is 10, right? We have 8, 2, and 6 here, so this is 4. 2, 4, and 6 here, this is 8. We have 34. This is 34. 42 minus 8 is 34. Divided by 2 is 17. 17 minus 9 is 8. So this is 8 here. That's an even. To sum up to an even sum, with one odd digit, you have to have another odd digit. Um, 18 minus 8 is 10 divided by 2 is 5. So this is 5. This is just an odd digit. 5 eliminates 5 here, so this is 7 and 7 to add up to 14. 14 times 2 is 28, plus 6 is 34. 8 has to be one of these 3 digits here. If this were 8, these would add up to at minimum 11, which is single digit cannot be. So this can't be 8 here. 8 can't be here because this would be at minimum 1 and 8 adding up to 9, but we have a 9 in the box. So therefore 8 has to be here. Eight's one of these two. We don't know which. Sum up. 22 minus 2 is 10. Sorry, 22 minus 2 is 20. Divided by 2 is 10. So these two digits must add up to 10. No 8 or 9 here. Remaining digits in box 5 are 1, 3, and 5. Whereas 9 in box 6, it must be one of these two because it can't be here, can't be here, can't be along the diagonal, or it can't be on the arrow because it adds up to 9. Which means 9 can't be here. 9 is on one of these two cells there. Can't be on the arrow. This is at most 7. It can be 1 and 2 potentially. So this is 3. So this is 3, 4, 5, 6, 7. Cannot be 4 because of 4 in the row. These two add up to 10. So if this is 7, well, this can't. So this is 7 and 3, 6 and 4, 5 and 5, and 3 and 7. This can't be 7 because of 7 in the row. So this can't be 3 here because of that adds up to 10 here. These have to be odd. So it's 1 or 3 here to add up 3, 4, 5. This is 14 here, so that makes this a 5 to add up to 14 minus 4 is 10, divided by 2 is 5. We have 1 through 4 here. This can't be 2, so this can't be 3 to add up to 5. We have 1 through 4 here. This is 5, 6, or 7. 5 eliminates 5 in the rest of the column. Neither of these can be 5 because they both see this cell here. This by being in the same row, this by being in the same box. So this cannot be a 3, 5 pair. It must be 1 and 7. 7 can't be here because of 7 in the row. So this is 1. That's 7. To add up to 7 here, we have to have 1, 3, or 5 here, which makes this 2, 4, or 6 to add up to 7. These both cannot be 1 because they both see this 1, this being in the same box, this being in the same column. So this must be a 3, 5 pair. And they are different digits because they're both odd, first of all. So it can't be 4 and 4. And both of these digits see that cell. So this cannot be 3. This is 1, which eliminates 1 here. This becomes a 3, 5 pair, which eliminates 3 and 5 in the rest of the row. So this becomes a 7, 9 pair here. So adding up to 3, 4, or 5 would have to have 2, 3, or 4 here. Right, with the 1. Um, 5 eliminates 5 in the rest of the box, so this can't be 5. That's 3. This can't be 3 or 5. It's 4. 3 eliminates, this is 3 and 5, adding up to 8. So this is 5 there. So to add up to 4, it must be 1 and 3, which is an odd digit. Okay. 4 eliminates 4 here. This can't be 3 or 5. That makes this 1 plus 6, adding up to 7. 1, 3, and 4. Eliminate 1, 3, and 4 in the rest of the column. So this must be 2, which makes that 3 to add up to 5. So that's even, odd, odd, even. 3 eliminates 3 here, so that's 5, which eliminates 5 here. Okay, remaining digits of box 1, we have 2, 4, and 9. And this can't be 2 or 4 because of 2 or 4 in the column. So that's 9, which eliminates 9 here. These are both even. This is odd. Okay. 1 eliminates 1 here, so therefore this can't be 4. These are all odd then. 1 and 3 is odd, 2 and 4 is even. 9 eliminates 9 here. Where's 9 in column 7? It has to be here. So this is odd. We have 5 odds in row 1. That eliminates odds in the rest of the row, so these are all even. And this must be the 3 because it's the last odd. That makes this 9 there as the last odd in column 4. This is 2 or 4 here because we can't be 6 or 8 because of 6 or 8 in the column. So that leaves the remaining digits in row 1 as a 6-8 pair. This can't be 8 because of 8 in the column, so that's 6, which makes that 8. This is 4, so this must add up to 10 again. So this must be 6 here. It cannot be 2 and 4 here. It must be a 1-5 pair, adding up to, because of the 4 in the box. And 5 can't be here because of 5 in the column, so this must be 1, which makes that 5, and both of these are odd, and this is even. Okay. 1 eliminates 1 here, so that's 3, and that's 1. These digits have to be less than 7. And this specifically... Let's add these up. Okay, so these have to add up to 9. There's no 1-8 available because of 8 in the box, and no 2-7 available. So this is either 3, 6, or 4, 5. 3 can't be here. 5 can't be here, which means this can't be correspondingly 4 or 6. Therefore, this is 3 and 5. It's an odd digit. This is 4 and 6, and it's an even digit. These digits, this digit must, these are at least 3. 1 and 2, adding, actually, even they can't even be that. 1 and 3 at minimum. So this has to be, this is 4 at minimum, which means this is 3 at maximum, cannot be 2 and 3 because of 2, 3 in the row. So this is 1, which makes this 3, that makes that 5. So this is 5 and 4, adding up to 9. This is 3 and 2, adding up to 5. 1 is obviously an odd number. So these two must add up to 6. So it's either 1, 5 or 2, 4, adding up to 6, but this can't be 2 or 4, which means this is both odds. This can't be 1, so this must be 5, which makes that a 1 to add up to 7. These do not have a 1 adding up to 9. This is at minimum 2 and 3. And it can't even have a 2. This is at minimum 3 and 4, which means this is at maximum a 2. So therefore it must be 2. So this is 2. This must be 3 and 4. This can't be 3 because of 3 in the column. So this is 4 here. No, sorry. This is 3 here. This is 4. Yeah. This is even. This is odd. And this is 4, and that's 3. To add up to 9. Okay. 2, where's 2 in this box? 2 cannot be here or here, so 2 has to be there. That's even. The remaining digits are 7 and 8. And the remaining digits in column 7 are 7 and 8. And this can't be 8 because of 8 in the row. So this is 7, which makes this 8, which makes that 7. So this is even. This is odd. We have odd here. Remaining digits in these columns are, in this box, are odd because we have 4 evens in the box. That leaves this as an even, and it's 2 or 4 because we have 5 odds in column 5. 7 eliminates 7 as a possibility here, so that's 3, which makes that 7. 7 eliminates 7 here, so that's 9, which makes this 7 there. Remaining digits of column 6 are 6 and 9. And this can't be 6 because of 6 in the row, so that's 9, which makes that 6. And the rest is probably just going to be normal Sudoku. So we don't need to color anything else. Remaining digit here is a 4. Remaining digits in row 2 are 1 and 5. This can't be 1 because of 1 in the column, so it's 5, which makes that 1. We have 8 ones. We know where the last one has to be. It's there. 2s, we don't really have enough information, I feel. No, not really. 3s, we have 1, 2, 3, 4, 5. We have 8 3s. We know where the last 3 is. It's there. 4, we don't have enough information. 5, we have 8 5s. We know where the last 5 has to be. It's there. 6s in column 8 has to be here. Which means 6 in row 6 cannot be here because of 6 in the boxes. Can't be here because of 6 in the column. So 6 has to be there, which makes that an 8. 1, 2, 3, 4. We have 8 6s. We know where the last 6 is. It's there. 7 in row 6. 7 has to be there. And we have 8 7s now. We know where the last 7 is. It's there. 8s. 1, 2, 3, 4, 5, 6, 7. We have 8 8s, so the last 8 is there. 9. In row 9, 9 has to be here. That's the only remaining place. We have 8 9s now. We know where the last 9 is. It's there. So now 2 in row 5 has to be there, which makes this 4, which makes that 2, which makes that 4, which makes that 2. And we are left with the 4 left. And that's the solution. Fairly straightforward, I feel. Just a lot of math. Not too much, not that much difficulty for the actual puzzle. I guess it was helpful to, yeah, the knowledge of odds and evens, right, is... But that's basically arithmetic, so I'm not sure how to designate that, but... Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.